So this is a tool regarding a latest SaaS solution, Datadrill. The Datadrill can extract key parameters from an oil and gas well completion report or end of well summary report or any daily drilling or summary report and present them categorically in a structured format in a dashboard. The Datadrill's advanced workflows start with running an OCR over PDFs to recognize the characters in the documents. The results are then passed through a proprietary deck engine which processes this data using our custom-tailored petroleum engineering prompts and an LLM model to optimize the performance and precision of the extraction process. Finally, this processed data is analyzed and cleaned using our ICE engine to filter out relevant data and remove incorrect or irrelevant information. Along with this, the ICE engine also extracts information on important pages containing this data, as well as relevant optional values that might serve as an alternative in the rare case that the extracted and processed data is still wrong. The DEC and ICE engines have been built using our extensive experience of petroleum and drilling engineering, along with our out-of-box knowledge of software engineering. These engines have been refined after immense testing to give you the most accurate results every time you use Datadrill. This makes Datadrill superior over other such solutions in terms of picking out accurate values. Now, going ahead with the Datadrill application, this is what login page looks like. Before going ahead with this application, let's first have a look at the standard oil and gas WCR or end of well report before uploading it to the Datadrill. So I'll just open one PDF, which is this Tele24. This is a typical WCR, is well completion report or end of well summary report. This, as you can see, this is of 94 pages. A usual report like this can be of anywhere between 100 to 500 pages also. This particular PDF is a typed one, as you can see. As I scroll through it, you can see. But some of these PDFs can be handwritten also, making it even more difficult to manually fetch the information. So I'll talk more about this PDF now. This PDF, this kind of PDFs usually contains information like name of the well, location of the well. This is the location map. Daily operations summary. Well construction details, complications encountered on day-to-day basis, and the steps taken to resolve these complications also. The well construction details, the formations encountered during drilling. This also includes the stratigraphy, pressure and temperature data recorded during the operations. There will be various charts and graphs there in the PDF showing different properties, rock properties, information like that, etc. So as we scroll over this PDF, it is evident that looking for a particular piece of information through this PDF would require humongous human effort, and yet it may not be exhaustive and accurate also. For example, let's say an engineer wants to find the deviation survey. I've already stumbled upon this page, which is the deviation survey data. For an easy piece of information like the deviation survey of the well, the engineer would have to skim through all the pages of the PDF and identify the page where the table is listed. So this is the table. Datadrill as a tool would not only extract this information in a tabular format, but also filter the page containing the relevant data from a range of pages. Imagine searching for the time lost for a particular failure, let's say, and having to skim through all the reports for that small piece of information. Datadrill does this work for you in less than 5 minutes. On top of this, Datadrill provides additional relevant options also of the data that are incredibly useful and may be correct in the rare case that the values returned after extraction are erroneous. So now let's just go back to our login page. So as I said, Datadrill can resolve all these issues. Uh, in this login page, you have to just put in your credentials and you are into it. I'll put my credentials. So this is a typical dashboard of Datadrill. This is how it looks. On the left hand side, there is this data filter, which gives the user access to the already created wells. So for demo purpose, let's start by clicking on the create well button in the data filter. So now I have a table. This is like an identification of the well that has to be filled in by the user before uploading the well completion report or any PDF. So I'll just quickly put some information for demo purpose. As you can see, I have already filled in the information. I'll just pick one PDF. So I'll pick the same PDF that I showed you. Here, I can select a single PDF or I can select multiple PDFs at once also. For this demo purpose, I have selected just this one PDF. Now I'll press the submit button to upload the data. In cases where more than one PDF is being uploaded, the application smartly picks up the required information from all the PDFs and does not depend on the diversity of the information recorded in the different PDFs. So now the well has been created and the PDFs has been uploaded successfully. It takes 4 to 5 minutes to process the PDF and extract accurate information and populate them in the different table heads in the dashboard. So while it is being processed, let's go to the dashboard, see what kind of data tables we have in the dashboard. So as you can see, there are 5 data tables. First, well location data, hole casing data, trajectory data, formation data, and complication data. So I'll detail more about this. The well location data is the basic identification of the well. Like it will show us, once it is uploaded, I'll be able to show that it shows us the country, the block name, the field name, the well name, the longitude, latitude of the well, all the identification data of the well. Then there is hole casing data, which shows us the well construction, that what kind of casings have been put in the well. The third one is trajectory data. It gives us the whole profile, the trajectory of the well. Then there is the formation data that includes the different formations that were encountered during drilling of that well. Then there comes the complication data, the last one. This complication data tab lists out all the complications that were encountered during drilling, so that an engineer can make an informed decision based on the complications that were encountered earlier in a particular field or a region. So let's go back to the PDF also once again. Okay, so this is the PDF that I was showing to you. Let's try and find, while the data is being processed, let's try and find the hole casing table. This is the location map. This page number 9. We have hole and casing cement details, right? So these are 12 quarter inch and 6 3 by 4 inch hole sizes. Against them, the casing depths are 9 5 8 inch and 4.5 inch. There are casing shoe depths, joints, casing weights, casing types, cement. Every data is there in this table. So once the data is processed, we'll try and validate this data if the Datadrill software has correctly picked up the values or not. I think the data must have been processed by now. So let's have a look at the. Okay, yes. So as you can see, the data has been processed. This is the well location data tab. In this, as you can see, there is well name, well site name, field name, country, well, bore, latitude, longitude, well type is whether it is a gas producer, oil producer, depth reference, total elevation, target reservoir, total depth, water mole temperature. All these data has been listed out. This has been picked up from the PDF. So let's just see if the block name, what is the block name that has been picked up. So upon clicking on the block name value, I have a page viewer that has opened from the right. This is a page viewer. So what it does is it gives the user option of values. These are two options that have been shown. If I click on any of the value, it will show me the page reference number from which page the value has been picked up, and whether it is right or not, I'll be able to validate it. So if I go through this, yes. So the block license number is PPL 15, right? So it has picked up the correct value and has given me the correct page reference number also. So that is the beauty of it. If I click save button here, see this value has been validated and it has turned green. So turning green gives an indication that the value has been validated. So the when a next user comes in and uses this value for decision making processes, he can use this value with a confidence over it, knowing that this value has been validated by one user earlier. So all these values have been picked up. So let's dig into more data tables. This is the hole and casing data. See, it is impressive to see that the data picked up from the PDF has been tabulated under two heads. One is the accepted values and the other one is suggested values. So what happens is, in this case, both the values have been picked up correctly, as we had seen in the PDF also earlier. These were the hole sizes and the casing sizes, 9.6 to 5 inch, that is 9.58 inch, and 4.5 inch, 4.5 inch. So in this case, both the correct values have been accepted, have been moved in the accepted value table. In case another value would have been picked up, it could have been shown in the suggested value table, like there has been shown a conductor casing. So if I, as a user, if I think that this value is correct, I always have an option to add new data here and move this value to accepted values table. And once I do it and I validate it using the page viewer option, it will turn green. And once it turns green, it will be a final value for other users to use this for decision making processes. So let's now move to trajectory data table. See, this is the deviation survey that we were trying to find in the PDF. This has been tabulated here very beautifully. The other one is formation data. So this is the formations that were there in the PDF. This is the name of the formation type, formation start, end MD, the formation description. So the another feature that we have here is, let's say this in this accepted values table, this PC40 sandstone value is incorrect. So what I need to do is I need to click on this. I will get this page where this value has been picked up from. I'll not get into this. I just close this. What I want to show it to you is that if I click this delete button, it moves to the deleted values table. So user always has an option to filter out the accepted values also for finalization purpose. If this value has been deleted by mistake, this can always be restored by clicking on this button. It again goes back to the table of accepted values. So this is how this works. So let's now go to the final data tab, that is complication data. In this complication data tab, we have depth-wise complication types like losses, ream wash, poor ROP, complication description, the problem resolution, how this problem is resolved, and the time taken to resolve this problem. Again, as in the other data tabs, we always have an option to open the page viewer and see if the values are correct or not. We always have options, suggested values here. We have an option to save this. Once we save this, this turns green. As you can see, ATS 1.2 hours has been turned green. We also have an option of deleting this value and moving it to deleted values table. See, this has been moved to deleted values. If I think I've deleted it by mistake, I can always again restore it. So this is it. This is all about Datadrill. To summarize, apart from the standard OCR and LLM engine, Datadrill's advanced DEC and ICE engines create a high performance and precision system to extract and tabulate all the relevant information from the standard oil and gas operation reports with utmost accuracy and reliability. We are always working on expanding Datadrill's scope of data extraction to provide the user with more data tables as and when required. To know more about us, please connect or visit www.brAIncrest.in.